So why spend all this time showing you this and practicing this in class? Well, the answer is really simple. The AP test is going to expect you to do these conversions. And they're not going to be clear-cut from the base 10 to base whatever. So they could be any different bases. The simplest way to do the calculation is to take the original number they give you, calculate it to base 10, and then convert it to whatever base you want to go to. That is the simplest way to do it. So I'm going to do an example like we'll do in class tomorrow, where we're going to take a base 16 number and convert it to a binary number, just like your computer would do in order to process it. So here's my example. I'm going to use the hex code. Let me find my hashtag here. A9B7F4. We'll use that one. And we're going to convert it to binary. And I'll show you an example and then we'll do one together. So, let's just simply go through and do the multiplication. What we have to account for with this is the conversions by power of 16. So we have 6 digits here, so we're going to have to always account for that whatever we take the digit of, we're going to take the digit times whatever 16th raised to the 5th is, and we'll do 16th to the 4th. Let's spread this out here a little bit so I can show you a little bit better. Then 16th raised to the 3rd, 16th raised to the 2nd, all the way down to our final digit. 16th raised to the 1st, and 16th raised to the 0. So this accounts for each of the digits that we have here. So this one will be with the 5th, the 4th, the 3rd, the 2nd, the 1st, and the 0. This is where the AP test will let you have a calculator, I believe. Now, 16th raised to the 5th is equal to, as I said earlier, 1,000,048. Oop, exponent is still on. Let me turn that off real quick. 1,048,576. When raised to the 2nd is equal to, or raised to the 4th, I should say, 65,536. Raised to the 3rd, now the numbers begin to get a little bit smaller. And you're going to see why we need these here in a moment. 4,096. To the 2nd is going to be 256. To the 1st will be 16. And to the 0 will be 0. Now, what we have to do is we have to take each of these numbers and multiply them by their corresponding digit. So here, we're going to multiply this by 10 because A is equal to 10. Multiply this by 9. Multiply 4,096 by 11. Multiply 256 times 7. 16 will be multiplied by F, will be 15. And 0 will be multiplied by 4. Take a moment, like I'm going to punch out these real quickly on your calculator. I did have to make one quick correction. 16th raised to the 0 is actually equal to 1. Now, for these numbers, what I have to do is after I multiply them out, I need to add them up together. So, the big number times 10, all we have to do is just add on a 0 to the end, so it's 10,485,760. Plus, then we're going to add the 65,536 times 9, which is 589,824. 4096 times 11 is equal to 45,056. 256 times 7 is going to equal 1,792. So I have to move my text box down so you can see it. 1792. 16 times 15, getting a little more comfortable with the math now, is 240. And 1 times 4 is 4. When you add those numbers together, and I'm going to do an underline here to signify that we are adding. I'm going to put an equal sign to let it show up. All of this is going to be equal to a huge number, 111,22,676. So that is 11,122,676 is what this is when we convert it to base 10. And now what we're going to do is we're going to take our base 10 number and convert it to binary. So here's our number 111,22,676. I want you to take a moment with a calculator and see if you can figure out the binary number by yourself. Because remember, all you're going to do is take this number. I'll do one with you here real quick. And you're going to divide it by 2 and get it equal to a number. So the next number is 55 million, or 5,561,338. So it does not have a remainder. So therefore, if I can get this to work, has a remainder of 0. So the last digit is going to be a 0. So take a moment to solve this out real quick and see if you're able to do it. I'm going to put my last digit there as a 0. Take a moment. Okay, because it would have probably put me over my YouTube video time limit, I went ahead and just did the math real quickly for you. And you can see, because we're just working with binary, that we're always dividing by 2, cutting in half. And the answer ended up being 101010101111111111010. Because remember, we construct this backwards. So this front 1 comes from right down here, and then we build backwards to build our number, our binary number. So that is how the computer views that hex code number. So something to keep in mind, because we are going to build a program that will do these conversions for us, is this whole process of having the program continue until the whole number is equal to 0. That's the main reason I'm showing you all of this math, is so we can build a program and know how to get the loop process to break as well as properly store the number. So, when you come into class tomorrow, we're going to do an activity similar to this, as well as begin to have you formulate how to begin to build this code.